Hello, today we're going to calculate the curl of u. The u is this vector field right here, and we're going to take the double integral of the curl of u and this normal to this figure we have right here. And the correct answer will be negative 2 pi. If you want to try it for yourself, go ahead. So let's begin. So if we're going to find the curl of u, we have to take the cross product of the vector field and the partial derivatives. So the partial derivatives is with respect to x, y, and z. And the vector field are right here. So we have x squared minus y, yc, and x squared. So to find the curl, we're first going to cover up this part, and we'll take the partial derivative of y with respect to x, which is 0. So let's write that here. Curl u equals 0 minus partial c with respect to yc. So that's just y. So we have 0, negative y for the first component. And we have negative, cover up this. We have partial derivative of x squared. That's 2x minus partial derivative of c of x squared minus y. That's 0. And then lastly we have plus, cover up this. We see that the partial derivative of x with respect to yc, that's 0. So we have 0 minus, and then partial derivative of y of x squared minus y, which is negative 1. So we're going to have negative 1 right there. And if you simplify this, you have negative y, negative 2x, and 1. So that's the curl. Now we just need to find the normal, and we can do the double integral. So our normal, if we look at this figure, it's a cone along the z-axis. So it's going to look something like this. And down here we have the xy plane. So z-axis, and you can think that the xy plane will run down here. So this angle would be 90 degrees. All right, so the normal of this cone, you would think if it was the flux, it would be pointing out of this cone. But since we're dealing with the curl and Stokes theorem, it's going to point down. So the normal of this will be, let's write it here. It's going to be 0, 0, and negative 1 will be our last component. So if we now do this, the curl of u times n, the normal, we're going to end up with the double integral of 0 times negative y, 0, 0 times negative 2x, 0, negative 1 times 1, which is negative 1. And since it is a circle in this cone, we actually have polar coordinates. So we're actually going to have the double integral of negative r dr d theta. So what are the borders? Well, we have c equals x squared plus y squared. That is the same as c equals r squared. So if you put the 2 here, you have 2 equals r squared, which means that you're going to have the square root of 2. equals r. So our upper border is square root of 2, and the bottom will be 0, which we can see here, right here. So we have square root of 2 and 0 for the borders of r. How about theta? Well, theta is going to travel around the entire circle because we have no other restrictions. So it's just going to be 2 pi and 0. So let's do this integral. We're going to have the outside integral left for theta, and we're going to have the integral of negative r. So that's going to be negative r squared over 2. And our borders was square root of 2 and 0. So square root of 2 squared is 2. So we're going to have 2 over 2, which is 1. So it's just going to be the integral of between 2 pi and 0 of negative 1 d theta. Alright, so if we take the integral with respect to theta, we get negative theta between 2 pi and 0, which is negative 2 pi, which is the correct answer.